So now you've had a chance to have a go at some of the integration by parts problems. We'll look at a double application of integration by parts. So this is example 4. So I'll just copy and paste that into my notes. I'll kick off. So what we'll do is this time we're going to make this u and this dv by dx. Now you can probably see here that when I take the derivative of u, it isn't going to go down to a constant, it's going to go down to 2x. But we'll see what happens when we get there in the working. So u is x squared, dv by dx is e to the 3x. So take the derivative of the u, that will be 2x, and then integrate the dv by dx, and that'll give us 1/3 e to the 3x. And then we substitute these into the parts formula, uv minus the integral of v du by dx. So uv is this times this, so that's 1/3 of x squared e to the 3x minus the integral of this times this, so that's 2/3 x e to the 3x v times du by dx. And I'm going to take this 2/3 out of the integral, and the reason is it's going to look a bit simpler when I do that. So now when I look at this integral, I still can't do this directly, and if you look at it, it looks very like an example we've just done. It's an integration by parts again. So what we're going to do is we're going to take that and do integration by parts on that, and then copy it back in later. So I'll go to the next page. In fact, what I'll do is I'll copy and paste that. Okay, go to the next page. Oh dear, I just took the box. I'll just copy it. Okay, so here we go. So I'm going to make that bit u and that bit dv by dx again. And one of the advantages of splitting this out on doing it as a totally separate calculation is I can still use u and dv by dx without getting muddled between them when I do calculations. So u is x, dv by dx is e to the 3x, so u by dx is going to be 1, so this has gone down to a constant. You can see this is probably just going to work out directly. Integrate dv by dx, that gives us 1/3 e to the 3x. So now uv minus the integral of v du by dx is uv, that's 1/3 of x e to the 3x minus the integral of v times du by dx, and that's just 1/3 e to the 3x dx. And as usual, I'm going to take that third out of the integration. It's not mandatory, you can leave it in, but I think it makes things look a bit simpler. So 1/3 x e to the 3x minus 1/3 e to the 3x over 3, plus a constant. When you integrate e to the 3x, you get e to the 3x over 3. And now I'm going to tidy that up a bit. 1/3 of x e to the 3x minus 1/9 of e to the 3x plus a constant. Now, I'm actually going to skip the constant bits here, okay, because this is a sub-calculation, okay, and I'm going to substitute this back into the other problem on the previous page, the bigger problem, and I'm going to put a plus c at the end of that, so I don't really need the plus c at this stage. So let me just copy this back in over here. So we'll go back down, and I'll start over here because it's quite a long calculation. So we've got, oops, something wrong with the pen there. 1/3 x squared e to the 3x minus 2/3 of, and then this, which we've already done. So we'll do, copy that in. Oops. There we go. Now I'll put put a few bits in there that I don't need. I don't need that equals sign. I don't need the plus c, because I'm going to put a plus c right at the extreme right hand end. So that's going to be 1/3 x squared e to the 3x minus, I'll multiply that through, that's 2/9 x 3x plus, and that's 2/27 e to the 3x plus a constant. And that's pretty much done. All we need to do now is try and factorize it out as much as possible. So let's do that. Well, let's take out e to the 3x first. Okay, that leaves 1/3 x squared minus 2/9 x plus 2/27 plus a constant. Now, you'll notice that if I multiply everything in here by 27 and divide that by 27, I'll take out the 27th there. So let's see, 1/27 e to the 3x. Now, 27 divided by 3 is 9. So, so a third times 27 is 9. Now, that means that this is 2 times 27 over 9. So that's 2 times 3, which is 6. So 6x, and then that's going to be plus 2, and then plus a constant. And that's all factorized out, and it does look a lot simpler there. We've reduced 3 nasty fractions down to just 1, and it looks much more straightforward. There's no further factorization that can be done there, and we just leave it at that point. So let's have a look back and see what we've done. So we split it into u and dv by dx, and got it down to this point where the integral is another integration by parts. So we went over and somewhere else did that particular integral, and then we came back and we substituted that answer back into here instead of that integration. You can see here in brackets, multiplied through, and then factorized, and that's it. So we'll do the next example in the next